All right, Math 8 students, here we go with lesson 6.4, analyzing graphs, and I put and functions up there because what we're doing in this lesson is we're really just connecting concepts and seeing how functions, building on what we've been doing with functions, interpreting them, analyzing them, classifying them, and seeing how that relates to them as representations of graphs, really. So not a lot of new stuff in here, just connecting those concepts. So if you are going through this, and as we talked about in class, try and do these notes without the video. See if you can go through and interpret all these graphs correctly, and then use the video as needed for help or as needed as an answer key. You should definitely use the video as an answer key, but also use it as help as needed. If you're really lost, go ahead, watch this as normal, watch it and follow along as we complete this. Okay. So let's go ahead and take a look at Explore Activity 1, Interpreting Graphs. So we have a roller coaster park that is open from May to October each year. So what we want to do here is, I just like to put this on here so that we know that this is May and this is October, right? So this would be May, June, July, August, September, October. So each of these kind of spots here indicates another month. And I just broke that down because I know that it's from May to October. The graph shows the number of park visitors over its season. So its season is from May to October, and this shows the number of park visitors over the season. Segment 1 shows that the attendance during the opening weeks of the park season stayed constant. What does that mean? Segment 2 shows, right? So if this is constant attendance for segment 1, this would be what? This would be increasing attendance. So the numbers of visitors increases. And I know that because what I'm looking at here is I've got visitors increasing over time, which is in months. Okay, so second thing we're looking at is, based on the time frame, give possible explanations for the change in attendance represented by segment 2. So this is kind of one of those, there's a lot of possible answers you could put in here. From May to June, what changed from that segment that was different in June and July? Well, a couple things that we've talked about is, it could be warmer temps, right? June to July is warmer. School's out, right? So the kids could be able to come during school. There could be a lot more people coming as families. And what happens up here is we have a tourist season, right? So it could be maybe tourists are visiting. Those are just some possible answers. Those are probably the big main ones that you might have picked up on if you were doing this on your own and you're checking your answers now. Definitely not by any means all of the answers. Okay, then we're going to go ahead and take a look at C. Which segment of the graph shows decreasing attendance? Give a possible explanation. So we're looking at the graph. We've got constant, increasing, still increasing for segment 3, but not as dramatically as segment 2. And then we are dramatically decreasing in segment 4 and continuing to decrease in segment 5. So segment 4 and 5 are decreasing. And possible reasons was, well, probably a lot of the opposite reasons as it was increasing. So cooler temps, right? That's going to affect a roller coaster park. Tourist season ends. That could be something else, right? School's back in session. Tourists go home. And then there's other possible explanations for sure. So what you're doing is you're just predicting, making reasonable guesses as to why that would happen based on the context of the graph. So we're going to go ahead and then reflect here. Explain how the slope of each segment of the graph is related to whether attendance increases or decreases. So what I want us to look at here is, what does the slope look like if it's increasing attendance? If it's increasing attendance, it's a positive slope. So positive slope indicates increasing attendance. which means that as we look at this graph here, if positive slope represents increasing attendance, a negative slope represents decreasing attendance. And so that's really all there is to that graph. So that's just a nice little introduction there to analyzing graphs. Something that I didn't do very well, but I really want you to make sure you do, is really look at those axes and see what it's measuring, because that's absolutely going to change how you interpret that graph. What is related to what? Time is related to visitors in this case, right? And visitors is our y-axis, which means visitors depends on time of year, right? So keep those things in mind as you're going through this. Let's take a look at the second graph that we've got. So this one is matching graphs to situations. And the situation here is that Grace, Jet, and Mike are studying 100 words for a spelling bee. Grace started by learning how to spell many words each day, but then learned fewer and fewer words each day. Jet learned how to spell the same number of words each day. Mike started by learning how to spell only a few words each day, but then learned a greater number of words each day after that. So looking at our graphs here, we've got 1, 2, 3, and we've got words learned on our y-axis and time in days on our x-axis. So as time increases, as the number of days go by, and we've got increasing words as the axis travels up. So what we're going to do, first thing, is we're going to match the graph to the student who's studying for the spelling bee. So this line here represents our 100 word max, right? And that means that, in this case, just to connect some concepts, our unit rate would be our words per day, right? So just connecting a couple of concepts there. So let's go ahead and look at this one here. So this is a constant rate. So this is saying that as time passes, a constant rate of words are learned. So we look at Grace. She started by learning many, but then had fewer. Jet learned how to spell the same number of words each day. Well, that matches this one. So this one's going to be Jet's graph. So Jet is done. Then we've got this graph here that is very few words learned per day and then dramatically increases to many words learned per day. So let's go ahead and look at Grace. She started by learning how to spell many words, so that's the opposite. So Mike started by learning how to only spell a few words, then learned a greater number. So this would be Mike, because he started by learning a few and then learned many. Which means this one, by process of elimination, is Grace, because she started by learning how to spell many words and then learned fewer and fewer each day. So describe the progress represented by A. So this is graph A, and we can see that this is a constant rate. So describing that constant rate and applying it to the progress made, or the progress represented, a constant rate indicates that the student learned the same amount of words per day. Meaning his rate of change did not change. His rate of change was constant every day. His unit rate was the same every day. B, describe the progress represented by graph B. So if we look at it, we have very few words learned per day and then many words learned per day. So it starts with a shallow curve. That becomes steeper over time. Meaning the the student learned few words in the beginning and then learned many. The student learned only a few words per day initially. Then learned many words per day. Okay. And so guess what? In C, we are describing the progress represented by graph C. So that would be many words learned per day initially, and then very few words learned per day. So it starts with a steep curve. Then becomes more shallow. Oops, not becomes, becomes. Meaning, the student learned many words per day. Many words per day. Then learned fewer. Per day. So here in D, we're going to determine which graph represents each student's study progress and write the students' names under the appropriate graph. Well, we did that first. So we've got Jet as the constant rate, Mike as the few words per day increasing to many words per day, and Grace as the many words per day decreasing to few words per day. So let's go ahead and reflect on that now. What would it mean if one of the graphs slanted downward? So if you had a graph that looked like, right, this would be your words learned, and this would be your time. So if the graph slanted downward, it would look something like this. So this is something where, okay, well, they started out knowing all of the words, and then over time, they knew fewer and fewer of them, right? Because if this is learning, on this side, this would be unlearning going down. So they're forgetting words over time. So maybe they learned all these words for the spelling bee, and then as time went on, they forgot them. So it could be, as the graph goes down, students started by learning or knowing all of the words, right? I'm going to say students started knowing all the words. And then forgot them over time. Oops, OV over time, right? Because as time goes on, they're decreasing the amount of words that they know or the words that they learned, and so they would, over time, be forgetting. Okay, let's go ahead and take a look at that third graph now, which is sketching a graph for a situation. So we've got Miss Sutton, who provides free math tutoring to her students every day after school. No one comes to tutoring sessions during the... Let the bell go. No one comes to tutoring sessions during the first week of school. Over the next 2 weeks, though, use of the tutoring service gradually increases. So part A wants us to sketch a graph showing the number of students who use the tutoring service over the first 3 weeks of school. So 1, 2, 3, first 3 weeks of school. So reading that scenario again, no one comes to the tutoring session the first week of school, but over the next 2 weeks, use of the tutoring service gradually increases. I'm having trouble reading today. Okay, so first week, nobody, no students, right? So no students that first week. And then the next 2 weeks, it gradually increases. So we're just going to make that curve up until we get to that 3 week mark. seem reasonable. Maybe it curves, maybe it's a straight line. Probably, it could be either a constant rate, constant increase. Maybe she gets the exact same amount of students that join every day, but maybe it's kind of a little bit of a curve. Maybe it isn't necessarily the same number of students every day. So we could look both ways. Miss Sutton's students are told that they will have a math test at the end of the 5th week of school. So here is week 5. How do you think this will affect the number of students who come to tutoring? Well, maybe nobody comes. Maybe many students come. But if it's anything like when we have a deadline coming up in this class, the number of students that are turning in work or coming to get help after school does increase. So we can say the number of students will likely increase. So we're going to go ahead and draw an increasing line up to week 5. Right. Considering your answer to B, sketch a graph showing the number of students who might use the tutoring service over the first 6 weeks of school. So we've got week 0 to 1, no students. Week 1 to 3, increasing. Week 3 to 5, we said it probably continues to increase. And your prediction could be different, so your graph might look different than mine. And then after the quiz, based on what generally happens after quizzes, is that attendance decreases. So we're going to say that week 6, that attendance starts to drop again. Maybe it doesn't, though. Maybe students are like, oh, I bombed that quiz, and maybe I need to stay in. So maybe your line plateaus for a little bit. Maybe it increases. But I want to say for my graph that the attendance probably decreases. So that's what I want to use for mine. So if Miss Sutton offers bonus credit to students who come to tutoring, how might this affect the number of students? Well, more students might attend all the time, right? If she says that, maybe from the beginning, maybe not so many because kids are like, oh, I don't need bonus credit. But as the year goes on, maybe an increasing number of students. So how might it affect the number of students? It might increase the number. Some students like bonus credit, some students don't. So we're just making predictions here. And then how would your answer to question 3 affect the graph? So what we can do here is if more students came, if she'd offer bonus credit, I would say that it would probably have increase and then maybe plateau for a little bit, right? Not get a whole lot of new people. And then it might just kind of go up and down for a little bit. But that's my prediction. I would say a greater number of students would use the after-school tutoring for bonus credit. What did I lost? Tutoring. Your prediction may be different, and so your graph might look different than mine. What you want to do is make sure that you can sketch a graph that matches your prediction. That's the big thing that you're trying to pull away from this activity here. And that is all that we've got for graphs today. If you have questions as you go through this and things didn't make sense, or if you got some wrong and you want to know why, or if your graph looks different and you want to know if it is accurate, then what I want you to do is go ahead and bring those questions in the class, because that's how we get questions answered. So make sure you're asking questions if you're not understanding. That's it for today. That's it for analyzing graphs. That is the last lesson in this chapter, also in this module. So we got a quiz coming up. You'll probably have one more video for this lesson, and that will be an optional video going through the review questions that you have in your textbook. So stay tuned for that. That'll be coming at a later date, the next couple days. All right, guys, I'll see you in class.